Hi everyone, so now we're going to be talking about how to solve quadratics using square roots. In the last video we talked about graphing, so using square roots is just another way we can solve quadratics. And the way that we do this with square roots is we're obviously going to use square roots. The goal is to get the x squared by itself on one side, and then once you get the x squared by itself, you can square root both sides. So let's just start going through some examples. The first example on your paper is x squared equals 81. So the goal, like I said, is to get the x squared by itself on one side. And in this case, it's already by itself because we already have the x squared just on one side. So once you get the x squared by itself, what we're going to do now is to get rid of the squared, we have to do the opposite of squaring something, which is square rooting something. So I'm going to square root both sides. But here's the deal. Whenever I square root a number, I have to put a plus or minus sign on the front of it. And I'll show you why, but in a little bit. But just know that anytime you square root a number, you always have to put a plus minus there. So now that we've square rooted both of these, we kind of talked about that the square and square root are opposites of each other, which means that they cancel each other out on the left side. So the square root cancels out with the square, and we're just left with x over here on this left side. And then on the right side, we have plus or minus the square root of 81. Now, the square root of 81 is a whole number. You could potentially plug this into a calculator, but the square root of 81 is 9. So I can write this as plus or minus 9. So, which means really that x could be equal to 9, positive 9, or x could be equal to negative 9. Those are my two answers. And if you remember from the graphing video, most of the time, like 90% of the time on these quadratics, we're going to get two answers, especially when we're dealing with solving with square roots. So the reason why let me just backtrack and tell you why we put this plus minus on there. The reason why we do that is because anytime you square a number, it's always positive. So if I were to take my answers, the 9 and negative 9, and plug them back into the original equation to double check my answers, I could say, well, all right, let's say that x is 9. So I'm going to say 9 squared is equal to 81. And does that make sense? Yeah, that makes sense because 9 squared is 81. But the other thing that makes sense is that negative 9 squared is equal to 81. Because any negative number that's squared turns out to be a positive number. So negative 9 squared is the same thing as saying negative 9 times negative 9. And we know a negative times a negative is a positive, which means that this would be a positive 81. And so that's why we have to have the plus or minus there, because our answer could potentially be plus or minus that. That's why anytime we square root something, we always put plus or minus next to the number. So on this first example, our answers are positive 9 or negative 9. Now let's go to the second example. And the second example is 5x squared is equal to 130. Okay, so last time I told you that we needed to get the x squared by itself first. And so the way we're going to get the x squared by itself in this case is by dividing each side by 5. Because the reason why I'm dividing each side by 5 is because right now the 5 is multiplying the x squared. So to get rid of it, we do the opposite of multiplying, which means we're going to divide. So I divide each side by 5. The 5s cancel out each other over here, and we're just left with x squared. And then we do 130 divided by 5, which gives me 26. Okay, now we have the x squared by itself. Once we have the x squared by itself, we're going to square root each side. So now I have the square root of x squared is equal to the square root of 26. But remember, we have to put the plus or minus there. And then the square root and the square cancel each other out. So we're just left with x. Then on the right side, we have plus minus the square root of 26. Now the square root of 26 does not simplify out pretty. So we're just going to plug that into a calculator. And the calculator gives me this never-ending decimal, but I'm going to round it to one decimal place, which would give me 5.1. And we always have to put that plus or minus still there, which means that my answers are x could be potentially positive 5.1 or x could be negative 5.1. All right, now let's look at the third example. So for the third example, we have 2x squared plus 9 is equal to 1. So once again, we want to get the x squared by itself, which means we need to get rid of the 2 and we need to get rid of the 9. The first thing we're going to get rid of is the 9 because it's adding, and so to get rid of it, we subtract. The 9's cancel out on the left side. We're just left with 2x squared. And then on the right side, we have 1 minus 9, which gives me negative 8. Still want to get the x squared by itself, which means I need to move the 2 that's in front of it. The 2 is multiplying, so to get rid of it, we're going to divide each side by 2. And then the 2's cancel out. Over here, we're left with x squared, and negative 8 divided by 2 is a negative 4. All right, so once we get the x squared by itself, we're going to square root each side. We're going to have the square root of x squared equals plus or minus the square root of negative 4. Now, potentially you know that the square root of positive 4 is 2, but when we try and square root a negative number, it doesn't work. You can even try it in a calculator. When you plug in the square root of negative 4 or the square root of any number into a calculator, it's going to give you an error. And the reason why is because we can't. Math does not square root negative numbers. And so anytime we have to square root a negative number, it doesn't make sense. It's not real. And so my answer here is that there are no real solutions, because I cannot square a negative number. Perfect. Okay, and then the last example is 3x squared minus 8 is equal to 10. So once again, we want to get the x squared by itself. I'm going to move the 3 and the 8. First, I'm going to move the 8 by adding it to each side. So we're just left with 3x squared because the 8's cancel out equals 10 plus 8, which is 18. Then to get rid of the 3, we're going to divide each side by 3. We're left with x squared, the 3's cancel out, is equal to 18 divided by 3, which is 6. Now that the x squared is by itself, we're going to square root each side. We get the square root of x squared is equal to plus or minus the square root of 6. That's square rooting a positive number, so we definitely can do that. If at any point you're nervous about it, you can always just plug it into a calculator to double check that it works, that the calculator doesn't give you an error. So then on the left side, the square and the square root cancel each other out. We're just left with x over here. And then the square root of 6 is not a perfect number. And so we plug it into a calculator, and we're going to round to the first decimal place, which gives me 2.4. So my answers are that x could be equal to positive 2.4 or x could be equal to negative 2.4. All right, and there we have it. This is how we solve quadratics using the square root.